and we are going to our final 3 talks for the day and for Texavania 2021. So I hope you're as excited as I am for the final few sessions. And with that, we start with a talk that I'm personally looking very, very much forward to. We have Cristina Scheau, who is the Director of Perception at Cruise. And obviously, for those of you who don't know it, Cruise is a leading autonomous company valued at $30 billion plus and building the future of transportation. Having formerly lived in San Francisco, I've seen this vehicles zipping along the streets very frequently. And she's leading the perception team that builds cutting edge systems and machine learning models to enable cruise cars to understand the world around them. And before joining Cruise, Cristina was leading a group responsible for relevance of search surfaces and recommendation systems at Facebook, where she built teams of 100 plus applied scientists and engineers. So I want to have you all join me in giving a very warm welcome to Cristina to Texavania.
Hi everyone, I'm Cristina and I'm super excited to be here with you today. I am actually both Romanian and American living in San Francisco, so I'm super excited to see events like Texavania in our community. Today I will be talking about what it takes to build a self-driving car, in particular focused on areas related to artificial intelligence, which is my domain of expertise. The intersection of the two domains, AI and robotics, which are needed for autonomous vehicles, it's incredibly exciting, having the potential to disrupt other industries beyond just transportation. I would be building a self-driving robot. It's complex. And in this talk, I will be covering 3 major areas, which are usually AI-based. Perception module, which has the goal to see the world. This is similar how the human has the eyes. Prediction module, which has the main target to forecast what the other agents are going to do. Behavior and planning module, which decides which action is the AV going to take, maximizing the safety and comfort. I would like to start by bringing context about how the AV is perceiving the world. So it is using multiple sensors, LiDARs, cameras, and radars, which have 360 coverage, thus having a more comprehensive signal than a human driver. The frequency of running the sensors is usually between 10 and 30 Hertz, helping the AV have fast reaction time. Multiple cameras cover long and short ranges, providing rich information for object detection and understanding. LiDARs provide detailed depth information of the objects, helping having precise 3D object detection. Radar provide instantaneous velocity information at short and long range, as well as helping the AV perceiving the world in various weather conditions. Given the rich high-resolution data, as well as the generous compute power leveraging multiple GPUs, multiple deep neural networks are applied, solving tasks like 3D object detection, classification, multi-object tracking, kinematic state estimation, attributes understanding. In the past 5 years, major breakthroughs happened in computer vision community around these tasks, and I encourage all of you to follow in particular CVPR conference publications for the latest development. Like any other machine learning task or AI task, the quality of perception depends a lot on the quality of its data. Driving in a density environment like San Francisco offers the opportunity to collecting tons of unlabeled data every day. As you see in these pictures, there is a long tail of objects that you might not have seen before. For example, there is this pedestrian with the car scenarios, or there are also difficult scenarios even for us as humans when we are driving, for example, unprotected left turns. For perception, for most of these tasks, we traditionally need human label data. We would get 3D object annotation in LiDAR space, 2D in camera space, and so on. This type of labeling, it is critical for any supervised learning, machine learning task, and in the same time, it is expensive to pay humans to create it. Nowadays, we go beyond that, leveraging millions of unlabeled training data by using simulated scenarios, as well as the latest research advancements in semi-supervised learning, active learning, and self-supervision. The next module that is AI-based that I like to talk about is called prediction. Prediction module has as main task to forecast timely what are other agents going to do. For example, in this scenario, we would need to predict that the white car will change lanes because in front of us it's a stopped bus. There are situations where predicting the future, it's a really hard task. So in those situations, AV tries to predict multiple possible outcomes as well as their likelihood, as well as estimating the uncertainty around those cases. Knowing, similar like a human, knowing when you don't know, it can help a lot. So the robot can have a cautious behavior even if the world is not fully understood. Compared with the perception task, where there is a dependency on human labeled data, as I was talking before, prediction task is self-learned. What it means that we can always generate labels by looking at the future and collecting cases where our predicted behavior was different from reality. So we can build this closed loop, which we call continuous learning machine, where every mile driven can become a rich source of information for our models. This loop has multiple components, from the driving behavior using error mining, where I identify scenarios where the machine learning model is doing mistake, and we extract error instances associated to it. The next step is labeling, which can be done automatically for prediction tasks. And after that, we do augment the existing training data with the new instances, and we are able to retrain the model. Because of the large data scale, even for tricky scenarios like illegal turns, we do have millions of observations for our models to learn from. The last AI-based module that I would like to talk about is called maneuver planning. This is where everything comes together to be converted in a decision of where and how to drive. It is an optimization problem among multiple dimensions. Safety, this is always the most important, and the goal is to be much better than a human. Comfort, it's about how smooth is the ride. We've all had taxi rides causing motion sickness with so many heartbreaks, and we are trying to design a system that is better than that. And lastly, we also optimize for the time for the ride. If getting from A to B is safe and comfortable, but it takes, let's say, 2x more time than a human driver, then most of us would still not use this service. Each scenario we encounter is a microcosm of complex decision-making and social interactions where safety must always take priority. And next, I would like to share with you a very special moment from last year when we had our first full driverless engagement in San Francisco. It is a video. I'm hoping that playing it will work.
And like this is going to be a big moment, but it's just going to accelerate from here. It's going to go from like one vehicle on a few city blocks to several vehicles on several regions of the city. And before you know it, we're going to be operating, at city scale in multiple cities.
All systems ready. Engaging in 3, 2, 1. Engaged.
There we go.
Oh, we're going driverless. Oh, it just happened.
After that very first drive, we did something you might expect. We did it again and again. There are no shortcuts on our mission to drive change. But every day, every hour, and every neighborhood, we get closer. We believe this is a drive worth taking.
Oh, this is the beginning. If you're watching, there's not that many opportunities in life to work on a technology that's going to disrupt the last 100 years of transportation, and probably not an opportunity for any of us to work on a technology that can have such a positive impact on society and on humanity. And this is our humble step in that direction.
Hope you enjoyed the video. It was a very special moment for us last year in San Francisco. And of course, as expected, the drive was boring, but this is what we are trying to do. We are hoping that our robot can drive as boring as you can imagine, so it is safe. For the next slide. I would like to talk about the impact of self-driving cars for our future. So imagine that you bring someone from the future and you explain that currently humans spend hours in this metal box which pollutes the environment, and as well as it kills millions of people per year. And one day we will look back and refer to the period between the invention of smartphones and mass adoption of self-driving cars as some bloody and embarrassing dark age. And our grandchildren won't believe our stories about having to constantly keep vehicles on the course manually, not that doing so cost of 1 million lives worldwide. And probably it will be initially similar how it was with the rollout of seat belts, where there were all sorts of objections from people that were preaching inertia. But we will get there, and as you see, software and AI continues to eat the world, and the sooner it's that distracted driver texting on their phone, the better off we will all be. And as closing, I just want to share with you what makes me even more optimistic. So if we can teach a robot to solve such a complex task like driving, we open up a new era, which is the era of intersection of artificial intelligence and robotics. And this new era has the opportunity to reinvent how do we do things beyond just transportation. If you think of manufacturing, if you think of household chores and so on, in the future, there is no reason we can't continue automating mundane tasks with the technology at a fast pace, and we would create more time for ourselves and for our families. Thank you so much for your attention. And if you have any questions about self-driving technology or about the content of this talk, don't hesitate to reach out to me after this presentation.
Thank you so much, Cristina. That was amazing. I hope we will have boring robots on the streets very soon. So thank you for this succinct presentation of what the future hopes and how we can make this planet much better for our, not only our children, but the grandchildren, as you said. So that was wonderful. So diving into a little bit, like, as we have a few minutes left, into like the technicalities, I'm really curious both of what has made you really excited about the advances in computer vision in the last 5 years, and what are you excited for the next 5 years in computer vision field in general?
Thank you, Philip, for the kind words as well as the question. What has been exciting is that in computer vision, given the latest development of deep learning and GPUs, we are actually able to detect and see things better than a human. There are many examples on internet, but you actually training neural networks, it becomes, you just achieve superhuman performance. And there are, as a human, there are many cases that are pretty challenging. There are occlusions, there are scenarios where you see a big part of the picture and you don't have maybe enough data of seeing what's next. And it's really exciting that computer vision now it's at a place where we can be at human level or superhuman in various tasks. Now, what's the future? One of the most exciting things are it's about self-supervision. So right now for computer vision, you still spend a lot of money for having labeled data, and as a consequence, you have all these limitations. And the latest research, it's a lot about self-supervision, about ability of leveraging tons of unlabeled data to still achieve similar performance. So when that inflex point is happening, it will be huge for us because we will be able to generalize way faster beyond the tasks that we've seen before.
That's a really amazing trend, both to democratize it in the current, like, last 5 years, as well as in the future, not needing like thousands of labelers that produce that data. I'm very excited about those two things as well, and I'm very, very much looking forward to that. And I hope that make our cars even more safer and more boring, as you said. So with that, I really want to thank you once more. I hope in one of our next edition, when we go hybrid, we can host you in Cluj. I think we don't need to show you Romania, but at least would love to have you in the audience to have the ability to interact with the people there. But again, once more, thank you so much for joining us virtually today. It's a pleasure and honor to have you. Thank you so much,
Thank
Cristina.
you so much. Have a great one.